Once again, good afternoon, everyone. Thank you so much for joining us as we present our Lightspeed Gate. The agenda for this afternoon is shown on the next slide. I'm going to begin by introducing the team here, and then we will move on to the motivation behind this Lightspeed Gate that we designed. We'll give you a brief system overview, as well as an overview of some of the logistics, the timeline and budgeting differences. And then finally, we will conclude with telling you a little bit about our future plans with the gate, as well as some of the things we learned through the development process. So first, a little bit about the team. I'm Noah Balzer. I'm the CEO of ShopLite Solutions. To my right here is Joyce. She is the VP of Marketing. She kind of oversaw the business side of things, looking into the competition and the current market. And then over here we have Calvin. He's our Chief Information Officer. He kind of was pretty key in some of the Arduino implementation, as well as some of the communication with professors at SFU. Next we have Brian Liu over there. He was our Chief Technology Officer. He kind of became the expert on RFID technology as we implemented it into our gate. Next we have Tim over here. He's our Chief Finance Officer. He did a lot of the part sourcing and finding the right prices and just keeping an overview on our budget as we move forward. And then finally we have Alex Yang over here. He's the VP of Strategy, and he also ended up being the head of the software team for this project. So now a little bit about ShopLite and how we came to be. We, as a team, we started brainstorming and meeting back in November of 2014, and it started in coffee shops, trying to think through ways of how can we make life more efficient or simpler or easier. And we specifically wanted to do it in a way that impacted everyday life. So we actually began by thinking about how we could improve life at home. Is there any way we could make everyday cleaning easier, or put the blinds up and down automatically, different things like this. And so we toyed around with the idea of even doing like an automatic robot, trying to make like a Roomba type device. But for us, the real innovation began when we started looking outside the home into other daily or weekly activities, and for us that was shopping. And now I'm just going to get Joyce to come up and tell you a little bit about the motivation behind the Lightspeed Gate.
So, as Noah just mentioned, we're trying to introduce or invent things that will change our daily lives, and we really thought very hard for like, what do we do every day? What does everybody do? And then we figure out we all do shopping. Everyone enjoys the pleasance and the convenience that shopping brings to us. However, we all hate waiting in line. Everywhere, no matter where you go, Costco, Safeway, even H&M, clothing stores, there's long lineups. You wait for half an hour just to get one or two items. Many stores try to think of ways to solve this problem. Some have express checkouts for people with less than 6 or 10 items. Some have self-checkout, so you can do it yourself. However, that doesn't save time at all. All they save is the paycheck for the cashier, maybe. But then we thought about the bottleneck for the time it takes to unload the things from the bag or from the cart and scan it and put it back. So here's our proposal to solve this problem. We're thinking, what if we have a gate like this, and you go through, and then it scans all the items and you can check out. A solution like this has very, very high demand. Just in North America alone, there are 761 Costco warehouses, over 1,300 Safeway stores, and over 3,500 H&M stores. And they're all looking for solutions to solve this problem. And now, I'll pass on. Oh, and there's competition. So, we're not the only one that thought about this. In Germany, the company IER, they thought about this. IER 960 self-payment kiosks. You put your items inside, and then it's all scanned. However, it only works for small items. Just like us, when we go to Costco, we buy a full loaded cart. This won't work. So now, I'll pass on to talk about the system overview.
Hi, so our main features of our gate is to use our RFID technology to achieve like wirelessly scanning items. So it eliminates when we unloading items on the cashier and loading back to our cart. And also we will do fast scan, which is less than 10 seconds, no matter how many items you have. We also have a user interface, which all the information of the item will be displayed on the screen. So after the customer can do normal checkout process after our scan. We also have our anti-shoplifting features, which to use weight to verify our scanning items. This gate is designed for all level or shoppers, including with us who just have items on our hand. We have several items with our bag, or if we shop heavily with at least like around 20 items. So now I will talk about our high-level design. First, our input is our RFID tags. The tag will be attached onto our items. And with our central reader unit, which is our antenna, it will receive the serial information from our RFID tags and send to our RFID module. Our location control unit will extend the range of our antenna scanning range. After we have the information, we'll pass it to our core system where we get our information from our database and display it onto the user interface unit. So Brian will talk about more on the RFID technology and the structure of our gate.
So yeah, this is our prototype, and so I'm just gonna talk about physically what you see here. So at the bottom we have a scale, and to avoid digging a hole in the ground in this room, we had to build a ramp for it so that you get the cart up. And we also can accommodate bags and other things. So but mostly for the cart. And so ramp, scale, and the sides here, there's an antenna on both sides, and they're able to rotate about the horizontal and vertical axes. And so this top piece here is just mainly to have another point of contact to stabilize the antenna. And most of our electronics are located in the bottom here. We made it mostly out of wood in order to reduce interference from using materials like metal. And also wood is easy to manipulate, and it was readily available, so that's what we chose. Next slide.
But you, in this final solution, you would use plastic wrapper?
Plastic would, I think, be better. Yeah. Less dense and
easier to clean.
Yeah. So the reason why we want to rotate the antenna is because antennas project lobes into space that are 3D, and each antenna has its own characteristic radiation pattern. And so within the lobe, that's where the antenna is sensitive, and outside the lobe is like a null space where it's insensitive. And so to avoid having items like not in the lobe, items that are outside the lobe won't be scanned. So we wanted to be able to move it around. The other option would be to have multiple antennas, but that would actually cost a lot more. So that's why we decided to have just the motors. So now Kelvin will discuss how we're going to move around the antennas.
So our location control unit is mostly to increase our scanning range. So first we have, you can see here and here that we have our location control unit, which is big of 2 motors at each side, a Arduino bar and a wooden frame. The motors is used to turn our antenna in left and right and up and down is 90 degrees in order to extend the scan range. And it's attached to around here and here. You can see here. Also, we have a ductile to balance the antenna in order to make it turn more smoothly. We also use our Arduino, which is a microcontroller, in order to control our unit throughout after we can code it. So now, Tim will talk about the central reading unit.
Hi. This is our central reading unit. So the central reading unit is basically our RFID module, which is a very high frequency transmitter operating at an ultra high frequency in the range between 902 megahertz and 938 megahertz. So as you can see on this block, we have the RFID module processor, which is the R2000. It's currently one of the best processors in the market right now. And as you can see down here, we have a 4 antenna ports, which are the connector to our antennas. So the signal will go out to the antenna, and the antenna will pick up the signal and then send back to our processors. So up here is our control panel. The control panel is basically allow the data transmit from our processor to the TCP/IP, and the TCP/IP port will send the data back to our computer software. The computer software is basically our backend software design, backend software. So you will see it in the later slides. So I will just very quickly walk through the CRU backend software design. So this is our TCP/IP, as I mentioned previously. And at the very first step, we will set up the equipment first, which it will reset the reader and set the power and frequency. We usually set our power to be 30 dB and our frequency between 902 megahertz and 928 megahertz. So that is a pretty nice range and power. And then we send the command to our reader module. So, but at this point, we don't know if the reader module are actually processing it. So we add a controller here. This controller is actually listening what's happening inside the reader module. So as soon as the reader module sends the feedback to the controller, either acknowledgement or something goes wrong, and the controller will allow this selector to select one of our antenna, which is this, and to pick up those RFID tag signal, and then it will send the command to the reader. So the reader will continue to picking up the RFID tags. So as you can see, I put a loop here, so which means the processor is a single processor, so we only process one antenna at a time. So it's like it turns this antenna on, and then scan it for a while, and then turn it off, and then it turn on another antenna, and then scan for a while, and then turn off that, and just keep looping until the time reach 10 seconds. So every data will go through the reader module and then go back to the controller at the end. And if something goes wrong, it will throw an exception, which tells us there's some error, so we can quickly catch up the error. And if the controller receives the useful data, like the serial ID from those RFID tag, it will pass to the UI. And I will happy to invite Alex to introduce the implementation for our UI. Thank you.
Hello guys, I'm really excited to talk about the user interface unit because when we are designing the user interface, we really kept in mind our original goal, which is to improve the customer's shopping experience by radically speeding up the checking out process, right? But we really put some hard thinking into how to design the user interface. We want to display the least amount of information, but also make it user-friendly and intuitive. So this is what it looks like for our startup screen for the demo project. You see on the top left is our company logo. Top right, it's a status label that always changes, depends on what state this software is in. And the bottom is a progress bar. It's a very dynamic visual feedback for the users so that they can see when it's going. Then you will see how much time is left for scanning. You guys will see it in the demo. And then in the central part, it's a table, and whenever a new item is picked up, it will just dynamically append it to the bottom of the tables. And when it's appending at the bottom right corner shows the total price. We'll calculate the sum of the price. So the user can always see, like, did I really get this item? If they didn't, they can click the rescan or something. But the rescan does not show up here yet. To start the whole process, you push the trolley onto the ramp and then click this start button, and it will prompt the user for the weight that you can observe from the scale. But this is just for the demo, but for the final project, we're thinking about making this whole process automated, like making the scan activated when there's like 10 kilogram more stuff put it on the ramp or something. This is just an idea. So after you click the OK on the pump up, then it will just start scanning stuff, and you see the sum of the total price is displayed at the bottom. if the user is unhappy with the scanning results, like if they bought more stuff than it's scanned, then they can click the rescan or ask for the, assistance. It's an easy way for them to recover from the failure, or they can also cancel the scan as well. If the result is all correct and the time 10-second scanning time is finished, then the checkout button will enable if the result is correct. The way we verify if the result is correct, we will introduce later. So that goes our user interface mockup. I'm going to introduce a little bit about the backend. This software project uses the traditional model view controller software architecture. So for the model for this software project, it's the SQLite database. We choose SQLite because it's a standalone database and it's easily distributable by to other team members. And this is read-only in our project scope because think about like when you are scanning stuff, you're not supposed to modify anything in the database. And once the controller gets data from the model, it will update the UI, which is a Windows Presentation Foundation project. We use that framework because it uses XAML and it's pretty easy to set up. This flowchart illustrates the logic behind the UI updating. So it goes from the top of the flowchart. You can see once the RFID reader gets some tags, it will send a callback to our software project. And the software project will try to parse the serial ID, which is attached to every single RFID tags, and check if this tag is mapped to any items in our database. During the test, we found that it's common that some of us will carry other RFID tags with us, like the access card to the lab or something. Then because that serial ID is not mapped to anything in the database table, we'll just ignore it. So if it has stuff, then we update the UI by appending it at the bottom. If it's not there, then we will just ignore it. And if finished processing other serial IDs, then we'll quit the scanning by stopping the antenna. So here goes most of the stuff about the user interface. I'm also going to give a brief summary about the timeline. This is our proposed timeline when we are planning the project. In reality, we planned for around 2 hours to order the parts, but in reality, it took much longer, and especially when it goes to ordering the modem. We also plan to project implementation phase to make it more like agile-like. But what actually happened is when all the parts arrived, we started working in parallel right away, and there's only one implementation cycle, which is when everyone finished their part and we were integrating it. And all the diamond shapes indicates the milestones that we set for our project. We were able to meet all of them. Next, I will have Tim introducing the project.
So as we can see here, we have our estimate and actual expense. So as we can see, our total expense is $12,078.8, which is higher than our estimate one. But we are still happy to see, like, after we add our location control unit and verification unit, we still keep our budget below $1,300. So we're also very happy to see many sponsors who support our project. The very first one is the SFU Engineering Society. They offer us a $600 for initial funding. And the second company is Innovinian. It's one of company in China, and they offer us many free RFID tags and have many support on our source code, which is the backend design I mentioned. And the third company is BC Scale Corporation. They very generously lend us the really high accuracy scale for free, so we can use it for about 2 months. So I have to thank you all this company to support us because they realized our future value of this product. So, Nova will introduce the challenges about this project.
So yeah, as I'm sure you guys can imagine, throughout the project we did run into some challenges. One of the largest challenges when it came to this was that we integrated a lot of different subsystems. We had the RFID technology interfacing with Arduino motors in our laptop as well as the scale, and trying to put it all in some sort of cohesive, slick design that didn't have wires everywhere. So that was definitely one of the main challenges. The second main challenge, as already has been hinted, is in initial testings with the RFID antennas, we were noticing poor performance on reading the tags. And so we initially didn't think we were going to be able to get very high results. And then that was when we kind of, we realized that changing the antenna angle made a significant improvement because of these lobes and these different null points where no tags would be read. And finally, we ran into some difficulties at the end when we were actually trying to have the location control unit change. We just ran into difficulty with the motors, and there was just more friction than we had anticipated, and things like that, which you'll see in our demonstration. So some of these challenges led to some changes in our original design. For instance, one of the things, we didn't actually plan on having the verification unit in our original design because we didn't think getting a high precision scale was within our budget, but because of the generosity of the BC Scale Company, we were able to integrate that scale. However, we have to manually input the weight into the system rather than have it automatically sent to the system. So that was one major change. And then the second major change was originally when we designed our gate, we actually thought that moving the antennas up and down and physically moving them was going to increase accuracy. So our original functional specification specified having motors on a belt and moving the antennas up and down on a belt. And like I said, we've hinted at quite often here, we actually found that didn't help as much as twisting the antennas. So that was a major design decision that we had to change that, and so that's what led to this location controller rather than the one before. And now I'm going to pass it back over to Joyce.
So just to refresh your memory, the Lightspeed gate that we've built allowed us to automatically scan all the shopping items using RFID technology. And in the future, we would like to do those improvements to our product. One thing is, like we just mentioned, we're going to change the main material from wood to plastic just because it's more durable, it's easy to clean, and it's water and liquid resistant. And also, we want to have better shielding for the gates because we're planning to have more than one gate in the supermarket or in other stores. So having more of them would introduce some kind of interference between them. So we'll have better shieldings with metal, with foam. From the hardware side of things, first we will replace the current motors with higher power because in the real industry situation, we'll have more dependencies. We're thinking we'll have more parameters that might add resistance, that might add friction to the system. So we're thinking we'll need higher power motors. And also we'll customize RFID readers to allow us for impedance matching for the liquid items. We'll either increase or decrease the power that the antenna has in order to impedance match so we can scan all the liquid or metal items. The last thing for the hardware improvement is the industrial floor scale. The one that we have is not that high accuracy. It has 1 kilogram error. So once we have the industrial floor scale, we'll have high accuracy, and also we don't need to have the RAM because it will be built in the floor. For the user interface improvement, just as Alice just mentioned, we'll have an automated start interface, so whenever cart goes onto the floor, it sends the weight and then will automatically start. And also we will have the integration of the scale reading into the system, because now the scale doesn't come with a very well written user manuals, that's why we couldn't integrate it currently. And also we will have the touchscreen as the current self-checkout setup at the stores. Here is our business case for our project. The current unit cost is $1,278.80. We are very positive that the unit cost will decrease due to large production, the economies of scales, and then it will decrease to $900. And this is a very conservative projection. We believe it will be lower than that. But given those figures, and we're going to sell it at $1,500 per gate. That will yield us to a profit margin of $600 per unit. However, to be real honest and realistic, for the very early stage of our company, we'll be mostly developing and debugging before we're selling to the customers. So we also figure out a few ways to raise funds, such as using crowdfunding websites such as Kickstarters, Indiegogos, and also we can go to consumer electronic shows and other communities, other platforms in order to raise funds. And also we'll talk to investors, and if they're interested, and then we can cooperate, and then we can get funds.
Oh yeah, so in conclusion, we just wanted to share with you a couple of the things that we've learned through the whole process. We definitely encountered how important it is to have good team dynamics. There was definitely moments when there was a lot of pressure, and we were feeling it, and parts weren't coming in. And I think it's pretty safe to say that overall we came out as a team, and we're very thankful for that, but we could definitely see how that's important. And another important thing was to have flexibility with the budget and the timeline. As you can see, we were off of what we initially projected, and so it was important to have that flexibility. We definitely learned time management and project planning skills throughout the course, as well as problem solving skills. And finally, just because of the nature of this particular project, we learned a lot about RFID technology, how to interface with it, as well as microcontroller coding and development. So, and finally, I just wanted to end with some acknowledgements of some people that have helped us along the way. Some special noteworthy mentions would be Miriam. We consulted with her heavily about the wireless antenna technology. That was very helpful. I also want to thank my dad and my father-in-law. My dad's here, who helped with providing the tools to build the gate, as well as consultation during the construction. And definitely to all our friends and family that supported us, even though we might have been a little bit stressed out throughout the process. Without your support, it wouldn't have been possible. So finally, do you guys have any questions?
Thank you. Another question. What if you have a metal cart?
Yeah, so as I'm sure you're aware, we've
That's
definitely
free, right,
bought-
from Target?
Yeah.
Nice,
We
nice.
definitely,
Now we know why Target went out of business. It's not the shopping carts.
we definitely foresaw that question. We designed our gate specifically to facilitate a plastic cart, and we haven't done tons of testing on it. However, we wouldn't say that it definitely won't work, because now that I've been more aware of carts, first of all, there are way more plastic ones out there than I thought.
Yeah.
And second of all, the metal ones do have quite a few holes, and so that a lot of signals will pass through, but we haven't had a chance to test it yet.
Okay. And then, so what if I just walk through? What happens?
So,
Because you imagine, 5 years from now, there might be 1 or 2 assistants in every supermarket, and are you gonna have like a gate in front that, okay, you paid, open, leave? Is that kind of what you're imagining?
well, so right now, we kind of looked at, so like as we said, the current solution, they have automated checkout process, right, where they have 1 person there for 6 of them. So in theory, someone could just walk through, right, but they do have an attendant there.
Yeah.
So as of right now, looking at that, I think we kind of designed it around that, so that you might have 4 gates with an attendant, just making sure no one does what you're saying.
Okay.
And also in the project planning, we also plan to have some LED on the top indicating like if it's red light, then you should stop. But also we also think about the gate that you were talking about. It's like
This-
On the system.
enter. Yes.
But this 10 seconds, it means that the cart has to stay there for 10 seconds, immobile, totally immobile.
Yeah.
And then the customer who is pushing it actually would go through the gate too.
Afterwards,
Yes.
yeah.
Okay.
After paying,
It would
right,
be-
with a card?
Yeah, well, they would just,
No,
you
no,
know,
not
scan,
after pay.
and then they go through, and then pay, and then leave.
Okay, yeah, because the customer could have some of the products in his pocket.
Well, that's just what I was about to ask.
Shoplifting, yeah.
Yes, so that's one of our extreme cases you'll see in testing.
Yeah.
Because of the angular rotation, if a customer is carrying an item on them, it'll actually be picked up, and the weights will be mismatched, and it'll say, please see an attendant or rescan.
Okay.
We'll also improve the process by having a line saying the next customer have to stand behind this line, so it won't pick up the next customer, but the only one.
Okay, and what if a customer consists of metal elements?
Yeah, so they do make metal RFID tags, which have a little thin layer of foam behind them, so that when you stick them on, they still scan. And we actually have tested that. We actually have a metal product with one of those tags on, so we can show you that. But there definitely needs to be that might involve some new packaging or different things.
What do you thought about it?
Yeah.
So, but that's the natural question after that is how much, like in Costco,
Yeah.
how many items have an RFID tag?
Yeah.
All of them.
Oh, go ahead.
You mean so far or in the future or what we're
Like
planning?
right now,
Right now they
None.
use barcode and none.
they use barcodes.
Yeah.
Yes.
So your project hinges on RFID tags becoming super cheap and printable.
So currently in our current research, they can go as cheap as few cents right now for the labels, because there are different ones, right? The one in the clothing store right now, they're the huge plastic ones, they're more expensive.
Yeah.
But then there's also labels that we use in our product.
Like the little white ones, the white
Yeah,
ones that are like about a couple
Stick-
millimeters
It's a
thick.
sticker.
The sticker, yeah.
They're actually, if you look into more like RFID tag research specifically, there is a ton of innovation on how to get them super thin, and there's actually those manufacturers who are making these tags are talking to packaging companies about having them integrated into packaging already, because people are already foreseeing that this is the future, something like this, right?
Yeah, I just googled RFID tag. This idea came up. That was the first hit on Google.
Definitely.
Imagine walking through a supermarket.
Exactly.
And in fact, $1,500 is not expensive because you could fire quite a number of cashiers.
There you go. Exactly.
Definitely.
I'm surprised you didn't raise it, but there is another side to it that is beneficial, and Andrew sort of peripherally raised it, is that if everybody that comes into the store has to exit via one of these, shoplifting becomes much, much lower, and that in its own right is going to decrease the cost of goods significantly. So you've got there's a marketing thing there as an angle that would be very useful.
There definitely is. One of the main reasons we didn't do that is because if someone really wants to steal an item, they still will be able to.
They'll
They can wrap
remove
in
it.
tin foil
Yeah.
and walk out. And so that's kind of one of the main reasons we
Or
didn't.
they rip off the label.
Exactly, or they rip off the label. So if someone really is a malicious trying to steal something, they can, and that's just the nature of anything, right? People can steal stuff right now too.
But that's going to catch the malicious or professional, perhaps, shoplifter. But a lot of shoplifting that takes place is casual.
Exactly.
In fact, my wife a few years ago picked something up that she wanted to buy and didn't realize until she got home she'd stuck it in her pocket. And oh my God, so she went back and paid for it. But it's, in some cases, totally inadvertent, you know.
So for such cases, you would install a paralyzer or something like that.
That wouldn't have been a good idea on my
It's
wife.
around $500. Yeah.
But what about groceries? Sorry, like produce,
Produce.
bulk items.
Yeah.
That's going to be a challenge.
Definitely. Is there someone else who wants to?
Okay, so far we are focusing on Costco, where they all have packaged goods. That's all. They all have weights in the system, and also some aluminum drugs and some other stores without grocery, without produce, without weighted produce.
But Costco pays one of the best employers in the continent. Actually, they pay their cashiers living wage. And you're gonna recommend a system that would replace what the biggest value actually in their company. You'd be surprised. They might not even want that in there.
But if right away when you think of Costco, what do you think of? Number one by far is long lineups. And
Yeah,
so,
I hate it. I never
exactly.
go. I
So
go once
there
every-
is a pro to it too, and
Alright.
so with the produce thing, we didn't implement it, but we did imagine what it could be. And so what we were kind of imagining, first of all, the stores might need to change the way they sell produce. That would be one thing.
Yeah.
Or the other idea is maybe you have something where people get to know the system, so they go, okay, I'll put my fruits on top. And then when you get to the gate, it goes, well, we know you have apples. Please take the apples out and weigh them. And you set them on a different scale. It says, this is the weight. Put the apples back. Please take the bananas out.
You
Pardon?
can stand on the scale, remove the apple, put it aside. By subtractive method, You can say how much hot dog you have.
Exactly, something like that. So we did imagine of what it could be, but we just realized for the scope of this 4 months, we were gonna have to not work.
I realize.
And in fact, you know, cashiers, maybe they pay living wages, but I immediately, when I see cashiers in action, particularly when there are long lineups and they are pushed to work as fast as possible, I can immediately see the movie with Charlie Chaplin working on this conveyor belt and going crazy.
Yeah.
I don't think it is, you know, I know that it provides.
It's not the most rewarding job in
No, it
the
isn't,
universe.
but, you know, people need
When you
to make
mentioned
money.
the user
Yeah,
interface,
but,
you
there are other ways of-
pointed out
Yeah.
a feature that the user is allowed
No,
to
I
rate.
think it is.
What was that for?
Oh, this is the future for sure.
What
The
is that?
scale.
Yeah, the scale shows the number.
The scale has a
but it's not
display,
connected, yeah.
because right now this process is not automated, so we manually input the weight in there. So at the end, this weight is going to be used later, like when we scan stuff, at the back end, we also calculated secretly what's the total weight, right? And then we cross-verify these two weight together as our simple version of verification unit. However, because of the limitation of our hardware, the scale isn't very precise to like 10 grams that unit. So we always have a little differences. So we hard code it to like 10%.
But what
Some
happens is
people
this,
put
the
the
weight,
kids on the cart as well.
Sorry?
Some
Oh,
people
yeah. Well,
put the kids, the
card
children.
itself, you will see it has a sticker. So it scan the card and know the card is there. Then it will just subtract by the weight of the
I'm
card.
just talking about kids. If you put your kids on the cart, that you'll get a message saying the weights are
Sticker in the
mismatched.
middle there.
Please remove.
Please
your
remove
kids.
the kids.
Or food and knowledge.
Oh, you have children.
Yeah.
Yeah, or you can tell them when put their weight in.
Or if the user is shopping by the bag, like their own shopping bag, they don't need to unload everything from the bag as well, because the tag on the cart it's not scanned, so we won't add in the weight of the cart in there.
Okay.
So when you cross verify.
So, but the weight of the customer is taken separately. so you could-
Yeah, we'll put little squares and you
Yeah.
only put your card there.
Oh, I see. So it's together.
Yes.
Ah, okay. Because, you know, if it is separately, then you could always add some more features like you are too heavy, buy our product which
It's special on diet products this week.
$10 off of diet products.
When they purchase dairy products, they
Actually, I like it.
do the rating
Yeah,
order and then they put a label, a
It's a
tag.
sleeper.
Can we do the same thing with the produce? We do the rating and
Too much, you know.
we attach.
They did a
The
good
system
job.
generates RFID tag for it. You can stick it to the.
Takes up like a little bit
We'll have to see their demo
So
here because they put a lot of work
what
into
we
that.
can do for that is we're flexible in that we can rate stuff to them too. So you could rate the weight to it and scan it and read that too. It's just that we didn't have a rater because that's pretty expensive. So we didn't have that.
Yeah, you can buy an RFID writer that actually puts different information on the tag.
So when you scan the tag, you not only get the serial ID, you also get all the information that's written to the tag. But we didn't get those kind of tag as which is pretty expensive.
And also the supermarket, they already have a system, a database with all the information. And we were thinking we'll just use those and go use the RFID and then you go to the database to get those information.
So all you need to do to pre-process is, they already have a database. You only need to map the thing to the thing, the serial ID to the item that's stick on with the label. That's all you need to do.
Okay, let's see this.
Let's see this.